Okay, so good day everyone. We are from Bitwise Labs of BSCS1A, and this is our final project for Fundamentals of Programming. We call this Stampede. Now, looking around the campus or here in our college, we know there are a lot of console applications in our batch in this final presentation and this final project, but most of them focus a lot on games, fancy UI, menus, and overall player experience. Now, we took a different path. We didn't just want to build a game or a simple console app. We wanted to build something that thinks. So we stripped away a lot of heavy graphics to focus entirely on raw computational power or logic for the engine. This is a high-performance chess engine powered by bitboards and the alpha-beta pruning, along with some minimax algorithms. So it doesn't just show you chess, because it calculates how to beat you at chess.
When we started the documentation for Stampede, we defined one critical constraint: performance. A standard C# application running on a managed heap is usually too slow for deep recursion. We needed a complete different architecture. We choose a console-based approach because the lack of graphic frees up computational resource. This allows for faster and deeper analysis, making the engine ideal for serious study rather than just casual play.
Hey po, ako po si Saab. So, my job was to break the architecture. And honestly, at first, it was easy. I would play E4 normally and the bot would freeze, and for a certain seconds, it would make it smooth. And it felt heavy. It needed to be instant, so that's it.
Ed mentioned speed. Here's how we got it. Obviously, we didn't use arrays because that's slow to represent the chess pieces. Instead, we used bitboards because in chess, the board has 64 squares, and an unsigned integer is also 64 bits in size. By storing the board as 12 unsigned long integers, one for each piece, we can calculate legal moves using bitwise operators like AND, XOR, and shift. By doing this, we are not checking squares one by one using a loop, because we are calculating the entire board in a single CPU cycle.
The AI logic relies on the minimax theorem, specifically a variant called negamax. Theoretically, the computer assumes that the opponent plays perfectly. If the opponent makes a mistake, the engine capitalizes on it.
But of course, brute force is impossible. Chess has too many variations, starting from openings and other to the endgame. So I implemented negamax with the alpha-beta pruning. Alpha-beta pruning is basically, let's say, imagine looking for a book in a library. If I check a shelf and find it's the wrong genre, I don't check every single book on that shelf because it's wrong. So I skip the whole shelf. That is called pruning. We cut off thousands of bad timelines so we can search deeper into the good ones. We also use iterative deepening, which means just solving depth by depth, solving depth 1, then 2, then 3, and so on, ensuring we always have a move ready for the engine.
So, it wasn't really smooth sailing. I found a funny bug where we called it suicide bug. I'd play against the bot and it would sacrifice its queen for no reason whatsoever. It was like it just gave up or something.
We traced this to a relative scoring issue. The engine was calculating scores from white perspective, so if white was winning, let's say +9, the bot was playing black, thought that was a good score, and tried to keep it that way.
That error was a sign error in the evaluate int method. So I added a simple logic flip in that specific method, and it instantly made the bot go from the suicidal player into a grandmaster. that plays logical and correct moves.
So we also had a wrong turn, a bug where the bot would crash or try to play white moves when it was black. But once we fixed the cloning method, we added the opening book.
So the opening book was supposed to be a external library na we're going to use, but it became too complex and I couldn't get it to work because it was such an old library that C# is not even accepting it. So I just hard coded a deterministic opening book. So it's basically just an opening book that plays specific moves after the player plays a move. Let's say e4, the engine would always reply with c5, which is the Sicilian defense.
So now if I play the Queen's Gambit, it responds instantly, no thinking required whatsoever, and it's just pure muscle memory and so forth. So we use spectre.console to render the ASCII board. It gives us colors, interactive menus, and a much more clean move log. So, after a long debugging sessions, Stampede is now a game that actively tries to make you lose, and it's really hard to play against.
In conclusion, this project documents the successful implementation of Bitwise state management and amazing search algorithms within a .NET framework.
So this means our project Stampede proves that you don't need heavy game engines to build something complex. If you manage your memory or RAM and control your bits, you can build high-performance AI or engine from scratch. This is
Bitwise Labs from BSCS1A signing off.
Thank you.
Wow.